Here is the recap of last video before going to proceed with functional connectivity. In last video we learned about functional connectivity. What is functional connectivity? It's the connection of different regions of brain and how to study. We have three modalities to study brain via functional connectivity: fMRI, EEG and MEG. And I also talk about the most common way is fMRI, which you can find in most recent studies. And then we see how to create functional connectivity using fMRI. The basic step is first pre-process your fMRI images, then convert into a brain specific template, and then use a specific atlas based on your own research, own data size, data sample, then divide it into targeted number of regions, and then you can calculate the Pearson correlation between the time series, and then for the normalization you can convert it into Z transform. And then we saw that why FC is important, because you can see that FC is altered with if you have mental disease or other kind of disease. FC also varies with increasing age. It also varies your behavior. So you can find many insights using one FC. Now we will dig into more basics about functional connectivity. In general term, we all know mathematics, and if we define FC is a matrix. In simple term, FC is a symmetric matrix divided. We all know symmetric matrix means which have equal number of rows and columns, divided by a diagonal equally. Now we know that FC is a symmetric matrix where the number of columns and number of rows are equal. That's mean that it's not important that you should study whole FC. You can choose only upper triangle or lower triangle for studying your FC. As it's a symmetric matrix, it means that the upper or lower triangle values are similar. That's why mostly we use upper triangle or lower triangle. It doesn't matter. So generally FC looks like this, which have 90 rows, 90 columns. It depends on your size of atlas which you are using. Diagonal equally dividing your FC into upper and lower triangle, and diagonal here is the highest correlation between the same region. Row showing the number of regions of interest, which common is ROI. So by row you can see that this FC using whichever atlas, it means this FC have 90 regions or 100 regions, and the values inside the matrix is showing the strength between or connectivity between each pair of regions. So in FC we have a pair of regions. Now let's see the example regarding functional connectivity. This is the functional connectivity. Mainly the functional connectivity represents the correlation. The most common correlation is Pearson correlation. This is the values for the correlation. Here FC is showing all positive correlation values. Inside is the connectivity between the pairs. Diagonal showing the highest connectivity between the similar regions of interest. And it's very important you should understand about functional connectivity. If you see the red column is the highest connectivity, and diagonal we have the maroon color, it means that these connections have highest connectivity, and it's obvious because it's the connectivity of that region between itself is called the self connection, self connectivity. So it will be higher. It can be negative, it can be positive, but here is positive correlation FC, and the blue means the lowest. So when you see the lowest color, and it means these regions of pair have lowest connectivity, there's no link between them. So we usually focused on the highest connectivity.